Hi, welcome to another episode. Today we're going to look at how we can automate VLAN configuration on your switch network. So if your network is big and grows bigger, at some point you might have hundreds of thousands of switches, so it becomes very difficult to manage all the switches one at a time. Like configuring VLAN, you have to jump from one switch to another and do your VLAN configurations. So it becomes very difficult to automate it and make sure that you do one configuration on a switch and it gets replicated to the entire switch network. So there is a protocol that does that for us. We call Vtp, Vlan Trunking Protocol. One of the properties of Vtp is called the Vtp Domain. The Vtp domain name identifies all the switches that are part of a particular Vtp. For example, if you are part of a Vtp domain, so that means you can receive updates and synchronize those updates in your VLAN database. So the other type is the Vtp mode. Vtp mode identifies or defines what Vtp level is the switch belonging into a particular Vtp domain. So there are three types of Vtp domains. We have the Vtp server, the Vtp clients, and the Vtp transparent modes. Another properties of Vtp is the Vtp configuration number, which identifies how recent the Vtp information is received by a particular switch in the Vtp domains. The higher the configuration number, the more recent the information. So this is incremented by 1 after every update made on the switch. There's also what you call Vtp Pruning, which is also activated on a server mode and it gets replicated to the entire Vtp network. So Vtp Pruning helps to make sure that if changes is made to a particular VLAN and there is a switch that does not have a port configured in that VLAN, the Vtp information will not be passed on to a trunk link going to that particular switch. So this therefore help and optimize traffic on the switch network with the Vtp broadcast messages. So here our switch network, we have basic configurations. All switches, switch 1, 2, switch 3, and switch 4 are configured with basic configuration. That's the switch host names. They are also configured with trunk links. All these links connecting to other switches are configured as trunks, and each switch is also given an IP address in VLAN 1. So as you can see here, switch 1 has 10.0.0.1, switch 2 10.0.0.2, 10.0.0.3, and 10.0.0.4 on the switch 4. So here on our diagram, you want to make sure that switch 1 will be our Vtp server mode and Vtp client on switch number 2, Vtp transparent mode on switch number 3, and Vtp client on switch number 4. So Vtp server mode has sub characteristics or properties if you like. The Vtp server can originate updates. That means it can create VLANs, it can modify VLAN and delete VLAN on the switch networks. So this information can be passed on to other switches, which is called Vtp update, and sent to the other Vtp switches, and they can receive this update and update their VLAN database. The Vtp server can also accept information or update from other Vtp servers on the switch network. Remember, we can have more than one Vtp server. We can have primary and secondary server in case one is not available. The other one can take over. The other Vtp mode is the Vtp Client Modes. We can also accept updates. That means if a VLAN is created or deleted from in this Vtp domain by a server, this information are sent. So these updates can be received by a client and also updates its local database. At the same time, the Vtp client can also pass on these updates or propagate it to the other Vtp switch networks. But the Vtp client does not originate updates. So it means Vtp client switch cannot create new VLAN or it cannot delete existing VLAN in the Vtp domains. The other Vtp mode is the Vtp Transparent Mode. Sometimes we call it radical switch. This Vtp mode does not accept updates in the Vtp domains. Vtp Transparent Mode can create its local VLANs, but these VLANs are not sent as an update to other switches. It does not also synchronize. That means if it receives update from other Vtp switches, the Vtp Transparent Mode does not implement those updates in its local database. The Vtp Transparent Mode can only forward Vtp messages to other Vtp switches. So if you look at switches, Cisco switches by default, they are operating all as Vtp server mode. So we can issue the command Vtp Status, and we can look at the Vtp informations. So here you can see we have the Vtp version is version 2 and the configuration number is 0 at the moment. So this is normally incremented by 1 after every change is made to the switch. So it's also telling us maximum VLAN supported is 255 VLANs. The Vtp operating mode by default is server. And another important thing is the Vtp domain name here is null by default. Vtp Pruning is also disabled by default, and once enabled on the server, it gets replicated to the entire switch network. So the Vtp local update identifier ID normally gets the IP address of that particular switch. So here we can see it's picking the IP address of this switch 10.0.0.1, which is the IP address that is assigned to the VLAN 1 interface. As you can see, interface VLAN 1 is assigned IP address 10.0.0.1/24. So now, first of all, what we're going to do is to make sure we configure the Vtp modes. So another thing is we make sure that all the switches operate as they are defined in topology here. So we start with switch number 1 and make sure this switch is configured as a Vtp server mode. So Vtp mode, we say it's going to be server. Okay, and then we have to also identify what we call the Vtp domain name. The domain name identifies which switches are part of this domain. Vtp domain name, we said we give it here in our lab as netlab. And so we want to secure this and make sure not any other switch can just join this thing. We give it a password. So Vdp password is Cisco. All right. So here, if we issue the Vtp status now, we should see some differences. Remember before we were seeing that the Vtp names configuration number was 0, and of course it's going to remain as 0 since no changes has been made so far. The Vtp mode was server, so this also we want to maintain, but the Vtp domain name has to change to something as netlab. So Vtp status now we can see the Vtp domain name is netlab. Okay, so if I display the VLAN information, so VLAN, we can see that only the default VLANs are clear. That's VLAN 1 and then the default from 1002 through to 1005. So if I go to the other switch or the second switch, now I can hardcode these ones as Vtp client. We go to global configuration mode, we say Vtp mode. Vtp mode is client. The Vtp domain is netlab. Vdp password is Cisco. You can use a stronger password in a live environment. You can save the changes. We go to the third switch, switch number 3. Global configuration mode, Vtp mode, transparent. Vtp domain, netlab. The Vdp password, Cisco. Finally, we go to switch number 4. Global configuration mode, Vtp mode is client. Vtp domain, netlab. Vtp password, Cisco. So if you display the VLAN information, we can see also that switch is only running default VLANs. So now let's go back to our Vtp server mode and originate some updates or make some changes. So remember here we only have the default VLAN, so now I can go there and create new VLANs. In global configuration, I can create a new VLAN, VLAN 10. I can give it a name as marketing. VLAN 20, sales. Display the VLAN information. Now I can see that this Vtp server has two VLAN created, the VLAN 10 and VLAN 20. So if I go to the other switches, like switch number 2, which is a Vtp Client Modes, it should also get those VLAN updated. Let me display the Vtp status. So Vtp status. Vtp status on switch number 2 is displaying now that configuration revision number has been incremented now to 4. Okay, and this was modifications configuration last modified by 10.0.0.1, which is suite number 1, which is our server that has made those changes. So it means this switch has received this information, Vtp information from this particular switch and updated its database. So that is the timestamp, and then now I can display the VLAN information, and I expect to see two new VLANs will be propagated here, VLAN 10 and VLAN 20, marketing and sales. So if I go to suite number 4, we should see the same thing. So VLAN, and now we can see the new VLANs are created, VLAN 10 and VLAN 20. Okay, so the Vtp status there. Also is showing us that this information was received from 10.0.0.1. Okay, the configuration number was incremented. So, but if I go to the radical switch or the Vtp Transparent Mode switch, which is switch number 3 here, we should see that no changes should be made to that switch. So you can see it's still running this default VLANs, because this will not accept this Vtp information and update itself. It will only pass or forward this message. Okay, so I can create a third VLAN here in suite number 1, which is operating as our server, VLAN 30, name I can say engineering, and if I go back to the other clients, we can see that these new VLANs will be added, VLAN 30 and engineering automatically, and the Vtp information will also updates. As you can see, the configuration provision number has incremented to 6, and it said it was modified by the Vtp server 10.0.0.1. Okay, so if I go to the radical switch, it's still not going to run all this. Okay, so but now when I create a new VLAN here, I said VLAN 50. Okay, and I give it a name called IT. Okay, so this VLAN is going to be updated in this switch local database because it's a Vtp Transparent Mode switch. But this VLAN 50 will not be propagated or sent to the other Vtp switches in the domain. We can verify that in suite number 1. You can see it's only running VLAN 10, 20, and 30, but not VLAN 50. So this switch can run its own VLANs, create it, delete it, and modify it. So if I go to any of these clients now, I cannot delete any VLAN. So here, let's try to delete one of these VLAN in the suite that is running as Vtp Client Mode. Go to Global Configuration Mode and say no VLAN 10, for example. So here you see the message Vtp VLAN configuration not allowed when device is running in client mode. So that means the Vtp client cannot delete any VLAN information. They cannot modify. They can only accept new changes and update their database or forward this message. So it's only the server that can do VLAN modifications. So if I go back to the server, I can delete the VLAN, say no VLAN 10. So if I display the VLAN information again, you can see VLAN 10 is gone. So if I go back to the switches that are running as client mode, so they should also update themselves and remove VLAN 10 from their database. So in suite 2, let me display the VLAN information. You can see VLAN 10 is gone, and the Vtp configuration revision number must be updated. So Vtp Status, you can see the Vtp has incremented to 7, from 6 to 7. Vtp can only be used to create and modify VLAN. So, but if you need to do individual ports assignment in each switch, you have to go to each switch and do the assignments manually. So that's all for Vtp. If you enjoyed this video, please subscribe to our channels, and so that you'll be notified with more videos that are uploaded in our subsequent episodes. So thanks, and see you next time.